Hello students, this is Mr. Allen here. We're going to continue our look at Chapter 7, Integration, and we are going to look at something called partial fractions. So we want to look at partial fraction decomposition with linear factors, and we're going to look at one with a quadratic factor. So let's say that we want to integrate this expression here, 1 over x squared minus 5x plus 6. We can do that actually using the methods that we've already discussed in this chapter, namely trig substitution. So after we complete the square, after we complete the square with the denominator, that's this, we will get the following. So we get a quantity with a variable x squared minus a constant squared. So since it's x squared, something squared with a variable minus a constant squared, let's go ahead and let a, which is 1/2, and let's let x minus 5, that's this whole this piece right here, equal 1/2 secant theta. So if that is 1/2 secant theta, then when we look, if we move this 5/2 over to the other side and we do the derivative, you'll get that dx is equal to 1/2 secant theta tangent theta. Okay, and let's not forget to, here's our reference triangle here. Remember, secant theta is 2x minus 5. Anyways, we continue through here. We make our trig substitutions, and then we clean things up. We get this, and then there actually is an integral for the cosecant of a theta, and it turns out to be the natural log of cosecant theta minus cotangent theta. We get like terms. We do a little simplifying, and then eventually we get the following answer. Now, I went through that very quickly because that's not the point of this video. The point of this video isn't to go through and show you trig substitution again. I would like to note, though, that there was a lot of work that went into this. However, is there an easier way? And there is. What we could have done is we could have recognized, potentially, that that one fraction could have been rewritten as the, in this case, the difference of two other fractions. And by the way, I'd like to remind you, guess what the integral of 1 over x minus 3 is? Well, it's the natural log of x minus 3. And what about 1 over x minus 2? Well, that's the natural log of x minus 2, which is precisely what we said there. So if somehow we had known that this fraction was equivalent to those two fractions, we could have done this much easier. So I'd like to show you how we got this result here. So if we have our 1 over this polynomial, the first thing we want to do is just do the prime factorization of the denominator there, or not the prime factorization, just factor it. And we need to recognize that this now can be rewritten as two fractions being added together, where the denominator of the first one is x minus 3, the denominator of the second one is x minus 2, and then the numerators are some number a and some number b, and those are actual constants. So if we multiply through by our denominator on the left, of course, if you multiply the denominator by that first fraction there, you're going to be left with just 1. And then on the right-hand side, if we multiply through the denominator, you'll see that the x minus 2 factors are going to cancel. I'm sorry, the x minus 3 factors are going to cancel. And then similarly, the x minus 2s are going to cancel over here, so you'll get b times x minus 3. Now we can go ahead and clean this up a little bit by just foiling and distributing things through here. So that'd be 2a plus bx minus 3b. And so let's do a little bit more work. So these two terms have x in them. So a plus b is x. And then we would end up with plus, and then this is going to be it's just going to be negative 2a minus 3b. Now I'm going to make a little observation here by adding a term that may seem kind of weird, but let me explain what's going on. So on the left-hand side, we've got 0x equal plus 1, and on the right-hand side, we got this. So this is the coefficient of x, and this is the coefficient of x, so 0 has to equal a plus b. Similarly, I'll do it in a different color. This constant has to equal this constant. In other words, 1 has to equal negative 2a minus 3b. Now, this is a very easy thing to solve on the left. So a is going to be equal to negative b. And now I can plug this in over here, and we'll get 1 equals negative 2 times negative b minus 3b. And it turns out that when you solve this, you'll get b is negative 1. B is negative 1. B is negative 1. And of course, if a equals negative b, then a is equal to positive 1. In other words, that recognition piece that I said on this slide, this up here, this is one way to get at that. So I'm going to skip this next slide and I'm going to do an example. In fact, I'm going to actually let you, this example is very similar to what I just did. So if we've got this x squared minus 3x plus 2, I'm telling you this one here turns out to be 1 over x minus 2 minus 1 over x minus 1. So it turns out that a is 1. In fact, I'll tell you that. This is what I'd like you to try to do on your own. A is going to be 1 and b is going to be negative 1 in this particular example. But let's go ahead and skip to the chase here. So now we can go ahead and integrate this. So we're going to integrate from 3 to 4 of a, which is 1 over x minus 2 plus, actually it's negative 1. That's okay. We'll leave it like that. X minus 1 here. And this is all with respect to the variable x. So when we integrate this, we're going to get the natural log of x minus 2 and then absolute value, then minus the natural log of x minus 1. And then we got to evaluate this from 3 to 4. So then that's going to give us the natural log of x minus 2 divided by x minus 1. And now we need to evaluate this from 3 to 4. And this is going to give us the following. It's going to give us the natural log of, let's see here, that'd be 2 over 3 minus the natural log of, and now I'm going to plug in 3, so that'd be 1 over 2. And when we clean that up a little bit, you'll get the natural log of 4/3. And that's our answer. Okay, notice I didn't do any trig substitution. And again, I would encourage you to go through the process like I did on this previous problem of figuring out that a is 1 and b is negative 1. Now, I'm just telling you right now, it is a coincidence that that's the case. I just wanted to do another easier one. They could be 2 or 3 or completely different numbers. All right, now I want to do an example with a quadratic factor, and that's this guy here. So we're going to try to integrate this using partial fraction decomposition. Notice that there can be an x that is factored out of that first term. So you're going to have 1, 2 linear factors with an a and the b on the top. But then we have this quadratic factor that can't be factored, this x squared plus 4. So instead of just putting a constant up there, we have to use a linear term, which means it has to have a variable times x plus d. So multiplying by the least common denominator on both sides gives us the following equations. Sorry, the phone's ringing there. And the left-hand side, everything will cancel in the denominator. And on the right-hand side, we'll be left with this. Now, here's an important observation. We've got to figure out what A is, what B is, what C is, and what D is. Notice that these two terms have an x in them. So if you let x equal 0, this entire term will go to 0, this entire term will go to 0, and these two terms will also go to 0. In other words, you'll be left with negative 8 equals a times the quantity negative 1 times 4. In other words, a is 2. That worked out kind of nicely, didn't it? In other words, what I'm trying to tell you to do is don't go foiling these out and expanding them. Okay, leave them alone. Similarly, notice that this term has an x minus 1 and this term has an x minus 1. So they'll go to 0 if you let x equal 1. And so this will go to 0 as well. We keep going. And then if x is equal to 1, we will find that b is equal to negative 2. Now the hard part on this problem is finding the c and the d. To find the c and the d, what you're going to have to do is you're just going to have to pick two different values of x, and then you're going to get a linear system. So if you let x equal negative 1, you'll get a is 2. You already know that a is 2 and b is negative 2. And when we work this out, we get this expression, which is very scary looking, but that just becomes 2 equals negative c plus d. If I let x equal 2, I get the following. When I clean it up, I get 8 equals 2c plus d. So now we have a system of linear equations, a fairly simple one that we can solve. It turns out that c will end up being 2, d will be 4. In other words, this monstrosity of integral will become the following. Now I would like you to notice something. Right here, I have a 2x because cx, the c turned out to be 2, and remember the d turned out to be 4. And now we can go ahead and integrate. Now when we integrate, this is going to be a natural log, that's going to be a natural, this is going to be a natural log via u sub. And then when we integrate this one, we're going to end up with an arctan. So we get 2 natural log of x minus 2 natural log of x minus 2. Here's where we get that u sub, and then there's that arctan. So there's the answer. A lot of work in that one. That's a tough one to do by hand. I have done 2 examples where there are distinct linear factors, and I've done an example with a quadratic factor. I am not going to do an example where there is a repeated linear factor, like if you had something like this, x minus 1 times x minus 1. I'm going to leave that for you to investigate on your own. There's some information in the text, or you can look up that online. But I'm going to stop there because we're getting kind of long. Thank you for your attention.